Okay, section 7.1, the voiceover for the solutions. As straight away as it can possibly get. Recall that I gave you this in your PowerPoint. Make sure you have that slide printed out and next to you when you do the final exam. It's like gold. I walked you through how to find these critical values, but I'm just flat out giving them to you. You get an 85% confidence level, the Z score that's associated at 1.44. So I've given you 2, 4, 6, 8, 10, 12, 14. 14 of them. You won't find one on the exam. You won't find a confidence level that I haven't given you the critical score for. Saves you the hassle. Be aware at 99% you're using 99% confidence level, you're using 2.575. All right, so what am I asking you? What's the critical value? What's the critical Z score associated with 98%? Well, there it is, 98%, 2.33. 2.33. Won't get much easier. Numbers 2, 3, and 4, I'm asking you to calculate the error. Well, here's the formula how you calculate the error when sigma is given to you, when sigma is known. All right, sigma being the standard deviation of the population. All right, so I'm looking for a 95% confidence level. The Z score that's associated with 95% is right here, 95%, 1.96. All right. I tell you what sigma is, 0.058. I tell you what n is, it's 53. I've included the fraction here, right here. I've included that in parenthesis, and I did that uh, just to point it out, emphasis. Okay, that's the word I'm looking for. You would not have to put the parenthesis in because the calculator is smart. It knows order of operations. It's going to multiply and divide before it does anything else. In fact, there's nothing else to do. It's going to multiply it and then divide. So you wouldn't necessarily need the parenthesis, but it wouldn't hurt. I did it once again for emphasis sake. Number 3, calculate the error when you're looking for a 99% confidence level. All right, and the Z score that's associated with that is 2.575. I give you what sigma is, 872. I tell you what the n value is, it's 76. You may wonder why I'm also telling the problem's telling you what X bar is. X bar plays no part in finding the error. If you wanted to find a confidence interval, then you would add and subtract the error from X bar. But for what we're doing, this is actually meaningless. All you're doing is you're actually stopping halfway. You're just finding the error. You're not going all the way to find a confidence interval. Number 4, 90% confidence level. The Z score associated with that is 1.645. I tell you what sigma is, 3.6. I tell you what n is. Pop it into your calculator, 0.250, right on the money, spot on. All right, number 5, we're going all the way now. We're going to actually calculate the confidence interval. But all the information is given to you, all right? You go to stat, you go to tests, you come down to number 7, Z interval. You are choosing stats. You don't have any raw data. You will have raw data when we start with section 7.2. Right now, we're working with statistics. By statistics, I'm telling you what n is. I'm telling you what x bar is. I'm telling you what sigma is. I'm giving you all the information. So all you're doing once you find z interval, is just plugging in the information. Sigma is 8.9. X bar is 90.6. N is 92. And I've discussed this here. Your confidence level is 99%. You can put in 0.99, but the calculator will accept just the whole number 99. All right, so in my estimation, without putting the decimal point, just put in 99. That'll work fine. And it gives you your interval. It also repeats back to you what X bar and N were, but you knew that already. What you're looking for is this confidence interval from 88.2 to 93.0. Once again, ladies and gentlemen, spot on. All right. Number 8, same thing. I give you all the information. I tell you what sigma is, x bar is. I tell you what n is. The confidence level here is 90%. Plug it into your calculator, z interval. Once again, You go to stat, test, number 7. And there it is, between 435 and 447, right on the money, no discrepancy. 7, repeat of 6 and repeat of 5. I give you everything you need to know. So what am I asking you to do? To put in what? 1, 2, 3, 4 values and hit enter. Between 230 and 236, there it is, letter A. Number 8, same thing, repeated. I give you N as 66. I tell you what sigma is. Sigma is 2.8. X bar, the mean score, 22.4. And I'm interested in a 90% confidence level. I pop it in, and my calculator returns 21.8, between 21.8 and 23. Right on the money. All right, so we flip the script now. There is no calculator function that gives me the sample size that I need to take in order to be, in this case, 95% confident. All right, but there's a formula. So I'm putting in 1, 2, 3 values, and I'm squaring the quotient. All right, so 95%, there's my z-score. Sigma is 593. There it is, divided by the error. I tell you the error is 120. I'm taking this quotient and I'm squaring it. Now, here's the deal. You've got to always round up. All right, rounding off, if it's 5/10 or more, you round. You round to the next digit. All right. If it's 4, 3, 2, 1, you would round down. But here, we always round up. With 0.8, you would have rounded to 94 anyways. No big deal. All right, here's a case where I put in my z-score that's associated with 90%, 1.645. Sigma is 28. All right, standard deviation is 28. And my error is 3.7. You're looking for a 90% confidence, and the sample mean is within 3.7. That means that that's the error. Within 3.7 pounds refers to, hey, 3.7 pounds below or above. Now, here's a case where this ends in 0. If it ends in 0, I'm not going to round up. That's the only time you don't round up. Any other digit, 1, 2, 3, 4, 5, 6, 7, 8, 9, I would have gone to 156. A 0, I keep it right where it is, 155. Number 11, just a repeat of the previous two. You get a 95% confidence level. All right, the z-score that's associated with that, z sub c, he calls it. It's a z-score 1.96. There's your standard deviation 536 right there, and your error is 128. Sample mean is within 128. That means that's the error. And here's a case where if I was rounding off, I would have called it 67, but in finding the sample size, you always round up. But here again, it wasn't like I was trying to trick you, like I had 67 for an answer and 68. No, here it is, 68. I'm not playing any games. It's just straightforward. And number 12, same idea as that hasn't changed. So obviously you got to have a formula by your side. All right. The z-score that's associated with 99%, there it is, 2.575 times sigma, which is given to you as 1100. And the error, you want to be within $200. And what you can't see here is at the very end, I squared this. All right, squared this quotient. And 200.6 rounds rounds up to 201. All right, didn't matter if that was a 6, a 4, a 3, or an 8. Anything other than 0, I'm kicking this up 1. All right, that's that. It can't get much straightforwarder than that. Hope this helps.